But let me just find out if she can hear me. Rufuno, can you hear me? Unmute your mic and talk. Can you hear me? All right, let's start. As I've said on our WhatsApp group, today we are going to do 3 important topics, of which is about associative and commutative properties. And then after this, we're gonna cover, let me check the other topic I've prepared for. We're going to cover 3 topics for the day. So the third topic is about the perfect square, which is a very, very interesting topic that you may take note of. So let's start with the associative property. I believe you can. Are we together?
I don't think she can hear you.
Okay, let me verify if she can hear me. Can you ask her to unmute your mic? I can see her mic is muted there.
Okay, let me try to call her. It's not connecting well.
Oh, because of network. Yeah, but I'm gonna fix her issue tomorrow. Yeah, her mother is coming with a laptop to me, of which I'm gonna install a Zoom. And I believe if she's using a laptop, it's gonna be much better than this. She might be having a network problem, but I'm gonna send her a recording immediately after the lesson so that she follow up. So let's continue with the lesson. So if she's not able to connect, don't worry about that. I'm gonna send her a recording of which she can make a follow up through.
And Adibao is not here.
Yeah, I sent a WhatsApp. It did not go through, and I then sent the link to her father. So I've noticed that he logged into WhatsApp now. So they might connect very soon.
Okay.
Or maybe you will want us to wait for them, maybe for 5 minutes.
It's up to you, say.
Okay, yeah, no, let's continue because it's we're going to have a recording. So they're going to get a recording because I think time may not be on our side. So now the first topic I want to do with you today is about the associative property. I've touched a little bit about this topic yesterday, but because of network connection, we're not able to do a lot. So associative property is one of the very, very interesting property. So let's take for example, we're given X, Y, Z as variables. So I just want to give you this definition with 3 variables. So we have variable X, variable Y, and variable Z. So associative property simply goes with, first is when we are adding, and then the second is when we are multiplying. So now let's apply the associative property on the addition operator. So if we are applying the associative property on addition operator, it means X plus Y plus Z, wherein we bracketed X, Y and Z. This will be exactly the same as having X plus Y in brackets and then plus Z. Do you see the difference between what we have on the left-hand side and what we have on the right-hand side? So on the left-hand side, we bracketed Y and Z. And then on the right-hand side, we bracketed X and what? And Y. Do you see that equation we have on the board? Let me pick this phone. I think it might be. Hello? Da. Da? A. Ndikufunza zve. Okay, let's continue. I was talking about the addition property, of which you can see on the left hand side we bracketed y and z, but on the right hand side we bracketed x and y. So that is what is called associative property, of which you can give an example so that you see how this is applied. Let's say in this case, as an example, we're taking this as an example. We have x which is equal to 1 and y which is equal to -2 and z which is equal to 3. Then now let's imply this on the associative property. You will see the property for addition, it will be satisfied with this value that we have there, wherein x is equal to 1, y is equal to -2, and z is equal to 3. So let's do this together. We start with the left hand side, wherein we are having yes. Yeah, don't worry. I'm gonna send a recording after the class. Don't worry for now. I'm gonna send it. I'm going to fix issues tomorrow. Your mother will come with the laptop to me, and I'll fix everything. So next time she's not gonna be having any problem.
Okay.
I will fix her issue. Okay. Let's continue. We start with the what? With the left hand side. So the left hand side, in this case, we are given x plus y plus z, wherein y and z are inside the brackets. So now let's substitute the values we are given inside this expression. So where we have x, we substitute 1 plus, and then where we have y, we substitute -2 plus 3. Now let's attend to that and see the final answer we get. So we know from the Bodmer's rule, I believe you remember the Bodmer's rule, wherein we're supposed to attend to whatever that is inside the brackets first, of which in this case is -2 plus 3. When we add these two, what are we going to get if we add -2 plus 3? What are we going to get if we add -2 and -2 plus 3? What do we get when we add those two values?
-5.
Do you
said -2 or -3?
It's -2 plus 3.
Oh, I thought it was a -3.
We are going to get...
It's 1.
We are going to get 1 in this case. So you can verify this with your calculator. -2 plus 3 is going to give you an answer of a 1, of which you can add them together, and you're going to get an answer of what? Of 2. So this answer we obtained when we use the associative property on the left-hand side. So let's use the associative property on the right-hand side and see if we're going to get to the same answer. So if we use the associative property on the right-hand side, of which is x plus 1 and then plus z, let's see what we're going to get. Where we have x, what are we going to substitute? We're going to substitute 1. And then where we have y, what are we going to substitute? We're going to substitute -2. And then plus what? Plus z, which in this case is what? Is 3. Now, according to the Bodmer's rule, what are we supposed to do? We're supposed to start by attending what is inside the bracket, of which is 1 minus 2. So what is 1 minus 2?
-1.
Is -1. And then you add -1 with what? With a 3. Do you see that? Then the answer you're going to get when you add -1 and 3, what do you get? 2. You're going to get an answer of 2. So therefore, because the answers of what we have used on the left-hand side and the answer what we have used on the right-hand side are the same. So it means it qualifies the associative property, of which it allows us, if you have addition throughout, you can decide to add whichever terms you like first. You can decide to add y and z, and then later you add x, or you decide to add x plus y first, and then later you add z. You are going to get exactly the same answer. So I would like to find out if we are all together up to so far. Are we all together up to yes?
Are you just repeating what you didn't teach us yesterday?
Yeah, this is what I've covered with you yesterday, but I'm going to add from that.
Okay.
Yes, so I've done the first part of which I've covered with you yesterday. Then now we're going to the second part, which I did not do with you. So this is for multiplication operator. So for the multiplication operator, we are going to apply the associative property. So again, in this case, let x, y, z be the variables. So we're going to do or to apply the associative property when x, y, z are the variables. So this is how we are supposed to do this. So x multiplied by y is inside the bracket, and then z is outside the bracket. And then on the other side, we have x, which is outside the bracket, multiplied by y inside the bracket, and z, which is inside the bracket. So according to associative property, it tells us that if you multiply x and y first, and then later you multiply z, it's going to be the same answer as when you multiply x and then later you multiply with y multiplied by z, which are inside the bracket. So it means you're going to get the same answer when you do that. Can we use the same example with x equal to 1, y equal to -2, and z equal to 3? Let's substitute these and then tell me what answer you get when you substitute this on the left-hand side of that expression. Don't use a calculator. Yes.
Is it x times y times z?
Yes, but you must multiply that as according to associative property. So we don't need to use a calculator here. It's the same thing as you have mentioned now, but make sure you don't use a calculator there to get the final answer. Are we all together?
Yes.
Yes, so that's how you're supposed to attend to this. Then now tell me, what are you going to get on the left-hand side when you multiply x, y, and z when x is equal to 1, y equal to -2, and z equal to 3? What answer are you going to get? What answer do you get when you multiply on the left-hand side?
We first apply the BODMAS rule and remove the brackets, and I got a -2, and then I times it with 3 and it was -6.
Very true. Did you all see how she get the left-hand side of that question? Did you all see how she get to the answer? Let me find out from you if you were able to notice how she gets to the answer of this. We are now on a multiplication operator of the associative property. So did you see how she get to the answer of the left-hand side of that expression? Or I should do
Yes.
All right, wonderful. But let me just take you through that, and then we're going to go to the right-hand side. So on the left-hand side, we have x multiplied by y and then multiplied by z, of which we are going to substitute these values which are given here, wherein x is given as 1 and y is given as -2, and then it's inside the brackets. And then from there, we multiply by the value of z, which in this case is 3. So what you're supposed to do there is to apply the BODMAS rule, which tells us that we need to attend to whatever which is inside the brackets first, of which in this case is 1 and what? And -2. When we multiply them together, they're going to give us -2, and then we multiply by 3, of which -2 multiplied by 3 is going to give us an answer of -6. So that is how you're going to get to the answer of what you have on the left-hand side. I believe we're all together with that. Then now, let's get to the right-hand side of that expression. Can you tell me how you get to the answer of the right-hand side of this expression we have here for the multiplication operator under associative property? How are we going to get to the answer of that?
So wait, let me first do it.
All right, yes, try it first. I'm going to give you an example which you're gonna attend, but this one, let's do them together. So I'll want you to do this question and then you tell me the answer you're gonna obtain when multiplying this, of which I'm gonna give you another example which we'll try. You apply these two operators under associative property. So what answer did you get and how did you get to that answer?
I first did the BODMAS rule again.
Exactly.
And then I obtained the answer -6.
All right. How did you apply the BODMAS rule on that one?
Because x equals to 1, I said 1 times open bracket -2 times 3 close bracket equals to 1 times -6, and it gave me -6.
Exactly. You first attend to what you have inside the bracket, right?
Yes.
And after that, you then multiply that with the x, you will get to the answer. So let's do that together so that you can see how we attend to this. So x in this case is given as 1, and y in this case is given as -2, and then we multiply this with 3. So from there, you then first attend to what we have inside the brackets, of which when you multiply -2 and 3, you're going to get -6. But we know -6 multiplied by 1 or 1 multiplied by -6, we're going to get the answer of -6. As simple as that. So it's a must that what you get here, it must be the same as that. Otherwise, if they're not the same, it means it does not satisfy the condition for multiplication operator under associative rule. So let me also emphasize this part because it's very critical that associative property for multiplication, it's simply telling you that if you start by multiplying x and y and then you multiply z later, it's going to give you exactly the same answer as multiplying z, y and z and then x later. That is what multiplication operator under associative property simply means. So the same of which I've explained under addition operator. So now let me give you a different question of which I want you to try, and then I'll give you 2 minutes to do that. And then you're gonna send to me via WhatsApp and see if you are able to get this right. So if you are fine with associative property, we are then going to commutative property. All right, this is the question I want you to do. Is an exercise of which is going to take only 2 to 3 minutes to finish. Let x be equal to 2, y equal to -3, and z, which is equal to 6. And the question say, use associative properties to obtain the solution. So now remember, associative property is generalizing the addition operator and multiplication operator. So quickly do this question where in x is equal to 2, y is equal to -3, and z equal to 6. So apply the addition operator and multiplication operator. So let me give you 2 to 3 minutes to attend to that question. So it's your time now. When you are done, send it to me on WhatsApp so that I see if you're getting it right.
Sir?
Yes.
You said we are using the same examples you gave us, but with the when x equals to 2 and y equals to -3 and z equals to 6.
Very true. Is these operators we're using here. Are we done?
Yes, I'm done.
All right. What answer are you getting for the addition operator?
I got 5.
All right. You got 5 when you apply the addition operator on the left-hand side and the addition operator on the right-hand side. Is that so?
Yes.
All
Yes.
right. And then for the multiplication, what answer did you get?
I got -36.
All right. Wonderful. Did you get the same answer, all of you? Did you get the same answer? Mukund?
Yes.
All right. Wonderful. Wonderful. Okay. Let me do the second property, which is very, very important. So it's what is called the commutative. The commutative property, not cumulative, it's commutative. It's commutative property, wherein in this case, we don't need to use 3 variables. We can explain the commutative property by 2 variables. They are enough for explaining the commutative property. So let me wrap here. So, and again, for commutative property, we have addition operator and subtraction operator. So it's addition operator under commutative property. So the addition operator, in this case, we're going to apply it to when we let x and y to be variables. Some they use a and b. Ourselves, we are using x and y. So where in a commutative property, it simply tells us that if you add x and y is the same, you get the same answer as when you are adding y plus x. As simple as this. What did we do here? We only interchange the position of the variable x and the variable y. So in the position of x here, we put 1. In the position of y, we put x. Do you see what happened on the commutative property?
Yes.
We change the position. We change the position of x and y. And then you're going to get the commutative property of the addition. Let me quickly go to the second property, because this does not give headache like the first one, of which you're going to apply the same thing to the multiplication operator. So on the multiplication operator, what are we supposed to do here? We're supposed to multiply now. We are multiplying variable x and variable y. So, but now the commutative property, it simply tells us that we can swap the position of these variables to have the same answer. So you can swap and then have y multiplied by what? Multiplied by x. And this will give you the same answer as when multiplying x and y. Are we all together with regard to the second property I've introduced there under commutative property?
Yes.
All right, let me do an example, and then after I'm going to give you an exercise to try. So this would be exercise 2. Let me say example 2, and then I'm going to give you exercise at a later stage. So now example, let x equal to 9 and y equal to -11. So these properties, they are very important when you are dealing with negative numbers. They are very, very important when you are dealing with negative numbers.
It's y equals to -11.
11, yes, it's -11. Yeah. So now the question again is to use commutative property. So commutative property stands for addition and multiplication. To obtain the solution. As simple as that. So now let's apply these 2 properties, the addition and the multiplication. So the addition on the left-hand side, we have to add, yes.
What is the difference between associative and commutative?
Let me explain the associative. So associative is about adding which variable first. For example, let me give this example. You see on the left-hand side, we are in total we are having 3 variables.
Yes.
Now the associative property, it tells us that adding variable y and z first, and then add variable x at later stage is the same as adding variable x and variable y and then add variable z at later stage. That's what associative property simply tells us in this case. Adding variable y and variable z is the same as adding variable y and variable z, and then add variable x at later stage is the same as adding variable x and variable y first, and then add variable z at later stage. It's exactly the same. Okay, let me explain this in Venn again so that you can all get this right. Associative property, iwe kurubuza uri ra add a variable y, ra add a variable z, and then rono add a variable mbili ngamuraho ra add a variable x. Zviva zvichifana namusi riko add a variable x and variable y first, and then add a variable z at later stage. It's the same. So, but we don't need to assume this because it's a different story when you are dealing with different problem. There are certain properties which don't apply in this case. So we cannot just assume that is the case. So this applies for when we're having the real numbers. If we are having non-real number, you remember we have covered real number, complex number. You remember the number system? You remember the number system we have covered the last time, ne?
Yes.
Yes. So this rule does not apply in all number systems. For example, for complex number, you cannot do this. You're not going to get the same answer. We cannot apply the associative property and cumulative or commutative property as it is. You are not going to get to the correct answer for complex numbers. So that's why we need to justify this, of which this is how we apply the associative. And then for commutative property, this is about exchanging the position of the variable. We're not having the brackets, you can see in this case. So this is simply to say, if you add x and y, it's going to be the same as first adding y and what? And x. Are we all together?
Yes.
Yes.
Right. Okay, wonderful. Okay, maybe before I proceed, let me tell you that this meeting is going to end in 1 minute 30 minutes.
1 minute 9 seconds.
1 minute 15 seconds. Ne? So make sure when it ends, you log in again using the same link. All right. I think let me take this moment to emphasize the second property of the commutative. So you can see again, we are talking about the exchange of the variable. So variable x multiplied by variable y is the same as multiplying variable y and variable x. You will see that these properties, they are very useful when we deal with the questions. So you must be able to apply these properties when we're dealing with complex questions, of which I will introduce to you at a later stage. So you must be able to remember the associative property and commutative property when we are dealing with complex questions. So otherwise, for now, let me wait for us to log into the new meeting, and then I will explain the example that we have on the board here about the use of commutative property to solve questions.